Hello everyone, I hope you all are doing well. So in this lecture series, we will be starting with the chapter probability. Now, before you start studying probability, it is recommended for you to study permutations and combinations before, because a lot of concepts from that chapter are going to be used in this chapter as well. And more or less an overview of probability you already have studied in your class 10th, 11th and 12th as well. So this chapter is nothing new from that. The only thing is that now there will be a bit more deeper concepts and a few new formulas as to how you can calculate probability. So without further ado, let's start. So in this chapter, we will be covering a few basic theory portion about probability and its formulas. Then we will be looking at a few algebraic rules. Now these algebraic rules you have already studied when you were studying sets and relations, where we studied about union, intersection, complement and all those things. So this is more or less the same thing. Then we will be looking at a few probability theorems such as total probability law, Bayes theorem, and then we will be looking at a few statistics portion in probability as well. So let's start. So what do we mean by probability? Probability is basically the possibility of any event or any thing happening. So for example, if I toss a coin, I can say that there are 50% chance of a head occurring and there is a 50% chance of tail occurring. So that 50% chance that I'm talking about, that is my probability. So now generally probability is calculated using this formula, which is number of favorable outcomes upon number of total possible outcomes. So for example, let's say, let me take the example of a coin only. If I toss a coin, what are the total possible outcomes that can occur? I can either get a head or I can either get a tail. So my total possible outcomes becomes 2. So total possible outcomes for this scenario becomes 2, because I can either get head or I can either get a tail. So what are my favorable outcomes? It is what has been asked in the question, or what is the event that you are referring to. So let's say if I say calculate the probability of getting a head. So I'm talking about just one head. So what would be your favorable outcomes? So number of favorable outcomes would become 1. And so if you apply this formula here, what would be your answer? 1 by 2. And so this is of course 0.5. And if you try to convert it into the percentage formula, you simply just have to multiply it by 100% and you get 50% as your probability. So of course, one thing that we can make out from this thing is that probability, we represent it in this format, probability of any event occurring. This E represents the event that is occurring. So probability of any event would always be less than equal to 100%. Of course, you cannot have the probability of an event occurring be 110%, right? So it has to be 100% or less than it, and it will always be greater than 0%. Or I can say that the probability of an event would be less than equal to 1 and would be greater than equal to 0. So this is the major thing that I'm talking about. So whenever you solve any type of question, of course, you're going to find out the probability in terms of a fractional number, which is between 0 and 1. However, if you multiply it by 100, you will get the percentage possibility of that event occurring. Now, let me take one more example for you to understand this probability concept more. Let's say if I roll a dice. So I hope you all know what is the total number of possible outcomes. Total possible outcomes for a die which has been rolled. What can I achieve after a die has been rolled? I can either achieve 1, 2, 3, 4, 5 or 6. I can either get one of these numbers, and let's say now my favorable outcomes depends on what has been asked in the event. So let's say if I say what is the probability of getting a 2 when a die is rolled? So you would say that the number of favorable outcomes is 1, which is 2. So your probability would be 1 by 6. And let's say if I say what is the probability of getting 2 and 4, or 2 or 4 when a die is rolled? So what can you say? That your number of favorable outcomes becomes 2. So your probability would be equal to 2 by 6. So this can be written as 1 by 3. And if, of course, in the question, if they ask you in percentage, you can simply multiply it by 100% to get your answer. So that is the main basic concept or skeleton of probability. Let's look at further topics. Random experiment. First of all, what is a random experiment? An experiment that can produce outcomes when it is repeated under same conditions, and of course the result is not predictable in advance. So there are two main conditions for a random experiment. What do we say? The first condition is that the event or the experiment that is happening, it must have more than one outcome. And the outcome cannot be predicted in advance. Cannot be predicted in advance. So this is what we call an random experiment. For example, tossing a coin, again the one that has been given here, tossing a coin. So how many outcomes are possible here? 2, of course. More than one outcome is possible. Head and tail. And outcome cannot be predicted before, right? You cannot be sure whether the tossing of a coin would give you 100% head or 100% tail. So the outcome is cannot be predicted. It is not predictable. That is why we call it a random experiment. Now sample space. So sample space is nothing but the total possible outcomes. So that if we write it in curly brackets, we call this a sample space. If we make it into a set, we call this set a sample space. So these are basically the total possible outcomes that can occur. So for example, for a coin, what would be my sample space? It would be head or tail. And for rolling of a dice, it can be either 1, 2, 3, 4, 5, 6. So this becomes my sample space. Now, let me tell you about a few more things. What if I say that I have tossed 2 coins together? So what would my sample space become? My sample space would be either I can get head in both the coins, head, or I can get tail in both the coins, or I can get head tail, or I can get tail head. So this can be my sample space. So basically what is this? 2 to the power 2, which is 4. 4 is my total number of possible outcomes for this type of scenario. So what I'm saying here is, if let's say a same random experiment is occurring simultaneously but for n number of times, then my sample space becomes 2 to the power n outcomes. My sample space would have basically 2 to the power n elements. So for example here, I tossed 2 coins together. So I have coin 1, I have coin 2. So now either I can get head or tail in first coin, or I can get head or tail in second coin. So if I was to check the number of combinations that can be made, so it can be head tail, or tail or tail head. So basically we get 4 combinations. Now what if I say if I tossed 3 coins together? 3 coins together. So what would be my total number of outcomes? I would say 2 to the power n, and so here n is 3. So this would become 8. So my total number of possible outcomes are 8. And what are they? Either I can get head in all the all the 3 coins, or I can get head, or I can get head, tail, or I can get head, tail, or I can get tail, head, or I can get tail. I can also get tail, head, or I can get tail, head, tail. So these are my total number of possible outcomes that I can get. So that is how sample space is calculated. So I'm repeating this thing again. If same random experiment is repeated n number of times, then my total possible outcome becomes 2 to the power n. Let me write it down here for you. If, or let me do it in the next page. If a random experiment is simultaneously occurred n times, then total possible outcomes. Now what is this total possible outcomes? This is basically my total number of elements in my sample space. Then total possible outcomes become 2 to the power n. So let me take one more example. What if I say two die are rolled? Again, simultaneously 2 dice are rolled. So what can be my total number of possible outcomes? It would be 6 square. Now, when I wrote 2 here, this is actually not 2. This would be total number of outcomes that can occur. Firstly, so this is outcomes to the power n. So for 2 die getting rolled, of course there can be 6 possibilities. So out of these 6 possibilities, any one can occur for the first die and any one can occur from the second die as well. So it becomes 6 square, that is 36. So I can have 36 number of outcomes for dice when 2 of them are rolled simultaneously. So what can be they? 1, 1. I can either get 1, 1 in both the dice. I can get 1, 2 in one of the dice and 2 in the other. My outcome can be 1, 3, 1, 4, similarly up till 1, 6. And here I can either get 2, 1, 2, 2 up till 2, 6. And similarly this can go up till 6, 1, 6, 2, and similarly I'm getting till 6, 6. So this is my sample space for 2 dice are rolled. So this is my sample space when 2 dice are rolled. So there are total 36 number of elements in this sample space, or 36 possible outcomes for this type of event. Now again, event is nothing but we've already discussed. Event is any type of thing or any condition that is occurring. So for example, let's say, what is the probability of getting a head when a coin is tossed? So getting a head, that is my event here. So as I said, we represent this, our probability, in this manner. So this here, E, is my event. So whenever I am supposed to write the probability, I write it in this way: probability of getting a head. So this is my event basically. This is how events are represented. Now there are different types of event. Let us understand. Simple event. A simple event is where there is just one favorable outcome. That is means, for example, in rolling a die, getting a 4. 4 is just, so my event would have just one element in its set. And basically event is nothing but a subset of sample space. So remember this thing. Event is a subset of sample space. So let's say if this event has just one element in it, then we call it a simple event. Compound event, if it has more than one outcomes or more than one element present in the set, then we call it a compound event. For example, in rolling a die, what is the probability of getting an even number? So I would say, what are my even numbers there? 2, 4 and 6. So I can get either 2, either 4 or 6. So my probability would become 3, because there are 3 events. Number of favorable outcomes become 3 divided by total number of possible outcomes. What are the total number of possible outcomes in a die? 6. So this would become 1 by 2, which is my 50%. Now what is a sure event? Sure event is when we know that the event will occur. It is 100% guaranteed that the event will occur. That means our probability of this event occurring is 1, or we can say 100%. So for such type of events, the number of favorable outcomes is equal to the number of possible outcomes. So for example, in rolling a die, what is the the probability of getting a number between 1 and 6. Of course, this is my total number of possible outcomes. This is my sample space. And I'm asking the probability of getting a number which is between 1 and 6. So, of course, this becomes my sure event. Impossible event, when it cannot occur at all. So, my probability of such events becomes 0. That means, if let's say if I roll a die, what is the probability that I can get 10 if I roll a die? Of course, it is 0, because that can never happen. So that type of event is known as an impossible event. Equally likely event. Equally likely means when each and every outcome has equal probability of occurring, then we call it as equally likely event. So for example, for tossing a coin, what is the probability that I will get a head? It is 50%. What is the probability that I will get a tail? It is again 50%. So we call this equally likely events. Now for example, a die, what is the probability that I will get a 1? It is 1 by 6. What is the probability that I will get a 3? It is again 1 by 6. So again, these two are also equally likely. Now let us come to the formula, which we've already discussed a lot. This entire formula, favorable outcomes by total number of possible outcomes, this is known as our classical probability, where what happens in classical probability is that all outcomes are equally likely. When all outcomes are equally likely, then only we can use this formula. Let's say if all the outcomes were not equally likely, that means let's say if I choose a biased coin. What do I mean by biased coin? Where the possibility of the events occurring are not equally likely. That means, let's say, let us assume, for example, if I toss a coin and there is a 60% chance that I will get a head and there is a 40% chance that I will get tails. That means this is not a equally likely event. This becomes an not classical probability space. So that time we have to use some other formula to calculate our probability. We will look into that in the further lectures. So for now, you have to remember this. Now let's solve a few examples to get our grip on probability and equally likely events a bit more.